The buoyant force. What is the buoyant force? Okay, this is simple enough, right? So the buoyant force is the density of the fluid, the volume of the fluid displaced times gravity, right? Density times volume is mass, so really it's just the weight of the water displaced, right? So we can figure this out. The density of the fluid is 1,000 kilograms per cubic meter, right? The volume here is 0.0295 times 0.0450 times 0.0450. And then G is, and these are all meters. And then this is 9.81 newtons per kilogram. Now, the way this is going to play out is the kilograms cancels the kilograms. The per cubic meters is canceled by all these meters, and so you will just end up with newtons, right? Okay, so let's do this. 1,000 times 0.0295 times 0.045 squared times 9.81. And I get that force is 0.58602 newtons. So we got that first answer, right? That's the buoyant force. Okay. If the wood has a density of 362 kilograms per cubic meter, what is its mass? Well, mass is just, what is mass? Mass is just volume times density, right? Volume times density. So it's going to be 0.20295 times 0.045 times 0.045. That's our volume of the block. That's a 0.0295, right? Times the density, which is 362 kilograms per cubic meter, right? So I'm going to take that number there. It probably would have taken me less time. Okay, so 362? All right. What is its mass? Its mass is 0.02162 kilograms times 9.81. This will give us its weight. Okay. So it weighs, the force of gravity on this block is 0.2121 newtons. What downward force would you need to exert to hold it under the water? Okay, so imagine that you've got this thing like this, and this block is like this under the water. Okay, and we have to exert a downward force, right, to hold it under the water. So what we've got is the buoyant force up of 0.58602 newtons. We've got a downward force of gravity of 0.2120 newtons, and we'll have an additional force, right? Force, I'll just call it force, right? And that's got to add to zero. We're holding it under the water, right? So I've got positive 0.58602 newtons, right? Minus 0.2121 newtons plus the force. That has to add up to zero, right? Okay, we can do this. It's just the difference between this, right? All right. All right. So this guy minus this guy. The force is negative 0.374 newtons, right? So what downward force? It would be 0.374 newtons. All right, now, you ready for a shortcut? Because that was a lot of steps, right? Okay, really it's going to be the weight of the object. The weight is mass times g, right, which is density times volume times g, which looks a whole lot like the buoyancy formula, doesn't it? Yeah. So this is, by the way, the density of the object. That's the volume of the object, right? Isn't the volume of the fluid displaced also the volume of the object as well, right? So we could just write that that's the volume of the object if the object is totally submerged, right? They are the same. So what we ended up doing here was just subtracting the buoyant force and the weight, right? So if I go the net force is going to be what the weight, the buoyant force minus the weight, roughly, right? So density of the fluid, volume of the object times g, minus density of the object, volume of the object times g. That will be the net force. Right, and whether it's downward or upward just depends on, you know, which thing prevails, right? Okay. Notice that can be summarized as this: density of the fluid minus density of the object, volume of the object times g. So I could have just done that, right? The density of the fluid, so parentheses 1,000 minus 362 times, and then we're going to go 0.0295 times 0.045 squared times 9.81. And I get exactly the same answer, okay? So this gives you sort of the net force. You're going to do a lot of these, so this is just a handy shortcut. All right.